Okay. So, let's start. Okay, so we are now on chapter 7, which is focused on the foundation of spectrophotometry. Okay, so from the word itself, spectro means light. Okay, or spectrophoto meaning light, no? And then metry meaning measurement. Measurement. Okay, so this is what we're going to do today. Okay, so we are going to understand how we can measure things with light. And is this related to your field? Yes, no. Why? For example, in urinalysis, what they do actually is that they collect the urine sample, di ba? Tapos, ang ginagawa doon, there is a paper strip na nilulublob doon sa urine sample. And when you submerge the paper strip, magkakakulay siya. Okay? So each color corresponds to a certain compound, no? For example, yellow for creatinine, orange for uric acid, no? Something like that. And then depending on the intensity of light, the medical technologies can know whether mataas yung concentration niya or not, no? So, yun yung application nito sa field nyo. Okay? And there's lots of application of this in all the fields of sciences. In biology, this is used to determine the chlorophyll content of a plant, no? In chemistry, gamit namin yan sa kahit anong bagay, no? Pero for medical technology, what I am aware of is yun nga, um, pag ginagamit 'to sa urinalysis na. Napanood ko 'yun sa YouTube, eh. So, in urinalysis, there's a paper strip, lulublob, magkakakulay. So, depending on the brightness of the color, you can measure the concentration of the analytes, no? So, 'yun yung idea dito. So, depending on the light, no, depending kung gaano siya kalinaw, o kaya gaano siya katingkad, kaya gaano siya kaliwanag, yun, you can measure the amounts of analyte, and that is spectrophotometry. So this will be our topic outline for today. So we will go through the concept of electromagnetic radiation first. So ito physics muna, although kwento-kwento lang. And then later on we'll go with the specifics of spectrophotometry. Okay? So let's review about light first because it is very fundamental in this topic. Okay. So in your physics, we know that light light exists in a very wide spectrum. Okay. So may light na visible, ito yung nakikita natin. But there are also light in other forms, no? Other spectrum of light. No? For example, the the light from the sun other than sa nakikita natin yung liwanag ng araw, it also emits UV radiation, no? Which is quite deadly, no? So, pag yan ay natapat sa skin nyo, then it can cause skin cancer. Kaya we need to use sunblock, no? There are also light that are invisible to the eyes. Okay? For example, the infrared, microwave, radio wave, gamma rays, X-ray, ultraviolet. So these lights are all invisible. Okay? And they have different energies. Okay? For example, in microwave, ito yung ginagamit sa microwave oven. Kaya nga siya, microwave. Okay? So in microwave, this is a quite big wavelength yan. Okay, so about 7 centimeter. So yan, it is used to vibrate molecules. Kaya yun yung ginagamit sa microwave oven. No? When molecules vibrate, umiinit sila. Kaya umiinit yung pagkain doon. Okay. So ultraviolet naman, ito yung nire-release ng araw. X-rays, this is what we use to get our X-ray films. Gamma rays, this is the thing I use in my thesis, no? I use this to carry out chemical reactions. Ayan. Infrared rays, ito yung ginagamit for um, hindi ko alam kung naabutan nyo yung cellphone na may infrared light. Pero ako, naabutan ko yan. No? Although 1998 lang ako, pero naabutan ko yan. Okay. So, yung infrared rays, yun yung ginagamit for remotes, for cellphones, no? Dati wala pang Bluetooth eh. So, we use infrared rays, no? And etc. So, radio waves, ito naman yung ginagamit sa radyo. Okay. So, ayan. So, light can exist in many forms, no? Kaya nga it is a spectrum, no? That's called an electromagnetic spectrum. Okay. So, it is an oscillation in energy, no? Sa paligid natin. And depending on the wavelength and the frequency of that, nagbabago yung types ng radiation natin. In spectroscopy, we are focused on the visible light now. So, ito yung nakikita natin. Okay. So, ibig sabihin yung nakikita natin, this is just a tiny portion of light, no? Pag sinabi kasi natin light, ito yung naiisip natin eh. Pero light can also exist in other forms. Okay? So, yan. For spectroscopy, we will choose visible and sometimes ultraviolet light to measure our substances. Okay? So, paano ba nagkaroon ng ganito? So, first pioneer for this idea was James Maxwell, which proposed that light is composed of electromagnetic waves. Now, so according to him, it is an oscillation in the space, in the electric field and the magnetic field. So, it is an oscillation that carries energy. Okay, and that oscillation can be characterized by wavelength, which is the distance from one peak to another peak. Okay, so that can be characterized by the wavelength. Okay, so yan. So the shorter the wavelength we have, the higher the energy. Okay, and according to him also, the longer the wavelength we have, the lower the energy. Think of it as ganito, no? So kunwari, ikaw lang mag-isa. Hawak ka ng string sa gitna mo. Tapos i-oscillate mo yung nasa dulo. So, it creates waves like this, diba? So, if you oscillate the other end very fast, lumiliit yung wavelength niya, no? Mas lumiliit yung distance ng increase-decrease ng wavelength, diba? So, yan. So, yun yung idea ni James Maxwell done. So, as you increase the energy, the wavelength becomes much smaller. Okay? Kaya if you decrease the energy, hindi siya ganun ka laki yung hindi ganun kaliit yung distances nila. Okay? So that's the idea of James Maxwell. And then, according to Isaac Newton, yung light daw can be separated into many colors. No? For example, we have a prism. So if you have a white light here, white light is actually composed of many different colors. Now we have the Roy G. Biv. No? Okay. So on the higher wavelength, okay. So let me denote wavelength as Greek letter lambda. If we have higher wavelength, we have the red, orange, yellow, green, and in the lower wavelength spectrum, we have blue, indigo, and violet. Okay. So, si Sir Isaac Newton yung may pakana niyan. Okay. Kaya makikita nyo sa Facebook, sa Google, if you look for Isaac Newton, you will see a picture of him holding a prism showing different colors. Okay. So, saan ba natin to magagamit tong review na to mamaya? No. Okay. So, anyway, so yun nga, sabi natin, light is an oscillation. No? So, light is an oscillation of electromagnetic waves. No? So, it can be characterized by wavelength. So, wavelength is the distance of one peak to another peak or one trough to another trough. No? So, yun yung distance. No? So, again, the higher the wavelength, the lower the energy. Higher wavelength, lower energy. And then the lower the wavelength, the higher the energy. So there is an inverse relationship for that. No? When we talk about frequency naman, it tells us how many oscillations can be done in a fraction of a second. Okay, this tells us the number of oscillations in 1 second. Okay. Okay. So for example, sino mas mataas frequency dito sa tingin niyo? So for example, this is 1 second mark. Okay. Okay. Of the two, sino mas mataas frequency? Obviously, ito nasa baba, no? Because it did many oscillations in 1 second than this one. Okay. So, unit of frequency is per second or hertz, no? This is hertz or per second. Okay. For example, here we have 1 hertz, no? Or 1 cycle per second or 1 per second. How about this one? This is 1, teka lang. 1, 2, 3, 4, 5, 6, 7. Oh, we have 7 hertz here, no? Or 7 per second. Okay, 7 cycles per second. Okay, so yun lang yung idea dyan, no? So, what is the relationship of frequency with energy? Okay, so according to an equation, later papakita ko sa inyo. Okay, so according to physics, if you have higher frequency, denoted by letter V, you have higher energy. And then the lower your frequency is, the lower your energy is. Okay. And you can also get the product of wavelength and frequency. So if you multiply the two, that is equal to c, which is the speed of light. Okay. And what's the speed of light? That's 3 times 10 raised to 8 meters per second. Okay? So kapag pinag-multiply mo daw yung wavelength and the frequency, you will get the speed of light. No? Okay. So for example, if I have wavelength of 310 nanometers, what is the frequency? So kunwari, ito yung problem natin. If I have a wavelength equal to 310 nanometers, hanapin ko daw yung frequency. Okay? Kung paano ko gagawin yan, madali lang. Just use the equation here. Lambda nu equals c. Okay? So this is lambda, Greek letter lambda. This is Greek letter nu, 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 equals to c. Okay? So wavelength times frequency equals the speed of light. Okay? So, solve natin yan. So we have lambda nu equals c. So since I'm solving for nu, that is c over lambda. Okay, so that's 3 times 10 raised to 8 meters per second. Yung lambda, this is in nanometers, ang unit ng ating CI meters. So you have to convert that into meters. So how? Remember your conversion factor. 1 nanometer is equal to 10 raised to negative 9 of a meter. Okay. So I will just simply write it as 310 times 10 raised to negative 9 meter. Okay, so let's solve for nu. 3 times 10 raised to 8. 310 times 10 raised to negative 9. So the frequency is 9.67. Let's say 68 times 10 raised to 14 per second. Okay. So that is the number of oscillations. Ang dami, no? So it's more than billions, no? It's more than trillions of oscillation in 1 second. Okay. So again, kaya yan. Okay, so yun lang. So again, if you are asked to solve, no? Kunwari sa quiz, if you are asked to solve for wavelength and the frequency, just use this equation. Okay. So always remember that the product of wavelength and frequency is the speed of light. The unit of wavelength is length, no? So it's usually nanometers, although you have to express that in meters. the unit of frequency is per second, no? So this is meter, this is per second, so multiply mo yan, meter per second. And that is the speed of light, okay? Which is 3 times 10 raised to 8 meters per second. Okay? Basic calculation lang yan. So I know you know that in physics already. Review lang naman tong part na to. Okay. So what's the importance of that, no? Ganito kasi. In the development of quantum mechanics in the early 19th century, no? So in the development of quantum mechanics, they found out that the energy, uh, the light energy can interact with matter. Okay? So may interaction yung matter and light, no? So parang yun yung motivation ng quantum mechanics. For example, um, yung bakal. Kunwari, kapag nagluluto ka, yung bakal, initin mo, it glows, di ba? Okay? So, nag-glow yung bakal. Ibig sabihin, yung matter, it can create light, no? Kasi dati ang akala lang nila, yung light ay energy, no? Pero, based on that idea, yung bakal, nagkukulay pula kapag sinilaban mo. Okay? So, ibig sabihin nun, that matter can also um, exhibit light properties. Okay? So, pwede siya maglabas ng light. Okay? So, there is an interaction between matter and light. Yun yung magiging foundation ng topic natin. Okay? So, ano yung mga dinaanan niyang processes, no? So, first, the development of quantum theory. Okay? So, one of the starting the pioneer person here is Max Planck, which said that energy is quantized now. Okay. So, the equation to be used to get the energy of a light is delta E equals h nu, okay, or hv, where h is the Planck's constant, okay? Kasi sabi nga natin kanina that if you increase the energy, if energy is increased, ba't tayo gumana ng ballpen ko? So if energy is increased, the wavelength is increased as well, no? So in equation, we can write that as delta E directly proportional siya with the nu. So to remove the proportionality, we have to introduce a constant, which is the Planck's constant, named after him. And the Planck's constant is this 6.63 times 10 raised to negative 34 joule second. Okay. We can also rewrite this in terms of wavelength. Okay. You know that C is equals to wavelength times the frequency. Okay. So solving for the nu will give us C over lambda. So we can equate this to hc over lambda as well. And dito mo makikita yung inverse relationship nila. Okay? So kapag yung isa nasa numerator, isa nasa denominator, that's inverse relationship, no? Okay? So ganun lang. So as the energy increases, the frequency increases, but the wavelength decreases. As the energy decreases, the frequency decreases and the wavelength increases. Okay? So, baliktad lang yung trend for the wavelength because nasa denominator siya. Okay, according to this equation that we derived earlier. Okay. So, yan na nga. So, ito yung start, no? Ito yung start ng foundation ng ating topic, no? So, according to Max Planck, that energy is quantized, no? And you can actually measure the energy of light using this equation. Just identify what wavelength you have or what frequency you have. You can get its energy. Okay. Next person of interest natin was Albert Einstein. Actually, um, dito siya nanalo ng Nobel Prize, hindi sa relativity, no? Okay. So according to Einstein, that light can interact with matter. Okay? So, yun. So, ibig sabihin, light is not just an energy. It can also act as a particle. Okay? So, dun na pumapasok yung dual nature of light. Light as energy, or light as wave, and then light as particles. No? Because light has this particle property, then it can interact with matter. Okay? So yun yung idea ni Einstein dyan. That at photoelectric effect ang ginamit niyang example, and he won the Nobel award for this. Okay? So yun lang. So yun lang yung basic background kung ano yung gagawin natin. So basically we understood before that uh, light is a wave, no? Light is an energy. Okay? According to James Maxwell and according to Newton, light can be separated into many colors, or basically there is a spectrum of light. And then later on, they found out that light interacts with matter. No? So according to Max Planck, energy is quantized, so you can get the energy based on the wavelength of the light. And then according to Albert Einstein, that yung light natin, it exhibits both wave and particle behavior. Okay? Kaya siya nagbe-behave with matter because of that particle behavior. Okay? So, yun yung idea niya. So, yun yung foundation natin. Okay? So, with those ideas they laid to us, no, we can now measure chemicals, no, that are unseen in the naked eyes. No? So, hindi natin makikita yung chemicals on the naked eye, but we can measure them depending on how they interact with light. Okay? So, there are two terms that we will use today, spectroscopy and spectrometry. Okay? So, spectroscopy refers to the study of the interaction between the light and matter. Okay? So, yun yung ating inaaral. So, nabigyan ko na kayo ng brief review about this. Marami pa yon actually. Yun yung inaaral ko ngayon sa masters. But for now, review lang gagawin natin. So that field of study is called spectroscopy when you're identifying the interaction between matter and light. And spectrometry, metry meaning measurement, okay? So you are going to measure the properties of light, no? And the concentration of your matter. Okay, so spectrometry yan. Okay? So yan yung mga terms na gagamitin natin. So please take note of that. Okay. So let's talk about spectroscopy. No? Okay, so spectroscopy muna, the way we study light and matter. So, marami kasing forms ng spectroscopy, no. Maraming ways to understand how light interacts with matter. There's a thing called emission spectroscopy wherein, for example, this is your sample, bigyan mo siya ng light, mag-e-emit siya ng colors. Okay? So, bigyan mo siya ng light, bigyan mo siya ng energy, it will emit colors. Ano example nun? Yung bakal, no? Kapag ininit mo yung bakal, nag-glow yun. So, that's emission. Okay? So, if you measure the amount of light emitted by that material, that's called emission spectroscopy. Okay? So, yan. Initin mo yung bakal, mag-glow yun. So, emission spectroscopy tawag doon. Okay, so hindi lang bakal, no? So you can also do this on matter. Okay. So one example of emission spectroscopy will be the chemiluminescence, which is, I know you know, ito yung glow sticks natin, di ba? If you break that, mag-glow yan, na. So what happens here is that it absorbs energy from the environment, which is enough to allow these molecules in here to glow. Okay. So yan. Typically, the chemical inside here is luminol. Luminol. Okay. Okay. And luminol requires just a small energy para mag-glow siya. Okay. So, ganun lang. So, may mangyaring chemical reaction. It will absorb the energy from the environment and then it will start to glow. So, yun yung isang application ng emission spectroscopy. Okay. The chemiluminescence, which can be found in your glow sticks. Another application will be bioluminescence. Okay, so apparently there are species, animal species na nag-e-emit ng liwanag. So, ano example nun? Yung mga Firefly yun, di ba? Okay, so yung firefly, they emit light. Okay. And then some aquatic material, some aquatic species also do that. No? For example, this jellyfish. No? Okay. So yun. So they do some chemical reactions in their body and they absorb energy from the environment, so they glow. Okay. So that field of study is called the emission spectroscopy. When your matter absorbs energy to produce light. Emission spectroscopy. Next one is the absorption spectroscopy. Okay. So what happens in absorption spectroscopy is this now. So you have your matter, it will absorb some of the energy. Okay. So for example, you have this incident light or the incident radiation. If it absorbs some of that energy, mas onti na yung matatransmit niya. Okay? So, kunwari, ito yung incident light. Pag inabsorb niya yung energy niyan, onti na lang yung tatagos sa kanya. Okay? So, by measuring how much will pass through the sample, you can determine the quantity or the amount of matter inside this. Okay? So, that's absorption spectroscopy. Depending on gaano karami na lang yung natira after the transmission, by comparing this with that, you can get the concentration of your sample. Okay. So that means the highly colored your material is, the more concentration there is na. Okay. Kasi kapag highly colored yan, di ba, ano nangyayari? We have transparent, then we have translucent. No? Kapag highly colored, translucent na lang yon. Not all light can pass through. So yan. So as long as nagiging translucent yung ating material, absorption yung nangyayari doon. It absorbs light energy. Okay? Kaya onti na lang yung light na tumatagos sa kanya. Okay? So one example of this would be the photoluminescence. Okay? So yan. So if it absorbs energy, it can emit light as well. Okay? And it can transmit other energy. So one of the materials used here is yung ginagamit natin nung bata tayo. Ito 'di ba pinapaskil niyo sa kisame. Okay. Para kunwari may stars at night, no. Ito naman yung mga glow in the dark na laruan, no. So they all use the concept of photoluminescence, no. So pinaghalong emission and absorption, okay? So the sample will absorb the energy. Kaya nga binibilad natin 'to minsan sa araw. So i-absorb niya yung energy from the light, and that absorbed energy is used to luminous, no. Okay, ibig sabihin lumiwanag. Okay. So yan. Okay. So yun lang. So yun yung mga forms ng spectroscopy. No, actually marami pa yan pero hindi na natin di-discuss, no. And there's also something called infrared spectroscopy, microwave spectroscopy. Okay? So, pero hindi na natin di-discuss yan. Basta ang idea lang dito is that when matter absorbs light, it emits energy. And also, when it absorbs light, onti na lang yung natatransmit niya. Okay? Those ideas can be made into an equation using this absorption law or the Beer-Lambert's law. So according to Beer-Lambert's law, we can measure gaano karami yung ating sample by just telling kung ano yung absorbed amount ng light. Okay? Okay. So there are two things that we have to know here. Transmittance and absorbance. So transmittance, ito yung ratio ng transmitted light and the incident light. Okay? So remember the picture kanina, ito yung incident light, incident. Marami yan. But since we have sample here, okay, i-absorb niya yung ibang energy. So, onti na lang yung matatransmit na. Okay? So, if you get the ratio of the transmitted and the incident, you will get the transmittance. Okay? So, you can multiply it by 100, so you can get the percent transmittance. The higher the transmittance is, ibig sabihin, konti lang sample mo. Kasi almost all the light passed through. Okay? So, if mababa naman yung transmittance mo, that means, ano, that means marami kang sample. Maraming colored substances doon. So, mahihirapan yung liwanag to pass through. Kasi ang dami nila dun eh. Okay? So, yun yung transmittance. So, the higher the transmittance is, mas maraming sample. The lower the transmittance is, um, I mean, baliktad pala ako. So, the higher the transmittance, the lower yung dami ng sample mo. Okay? And then the lower the transmittance, marami yung sample mo. Okay? So, yan. So, baliktad yung trend nila. High transmittance, low sample, kasi almost all light will pass through. Low transmittance, high amount of sample. Okay? So, yan. Absorbance, on the other hand, is the negative log of T. Para siyang pH, no? Ito yung H, ito yung dami ng liwanag, no? As yung absorbance naman, this is the negative log of that liwanag, okay? Para siyang pH. So, absorbance is, the negative log of T, no? So, that's negative log of this equation, okay? So, absorbance is equals to negative log of P over the incident light, okay? So, ano namang kwento nito? Okay. So, ang trend niya is ganito. Okay. So, the higher the transmittance, ang mangyari, the lower the absorbance. And then, the lower the transmittance, the higher the absorbance. Okay. So, parang din siyang sample. But this time, we are measuring the absorbance. No? So, ito na yung trend niya. Same pa rin dito. Okay. Pero this time, it is now absorbance. Okay. Okay, so from those equations, ayan, for example, ito. So we have this incident light, then this is our solution which contains the analyte. Siyempre, kapag maraming analyte, dyan, onti na lang tatagos. No? So that means mababa yung transmittance, which is mataas yung absorbance. Okay, note of that. Pag onti lang yung transmitted, ibig sabihin maraming inabsorb. Yun lang yung idea. Kaya baliktad yung trend. Okay. Okay. So anyway, pinapakita lang dyan yung way to absorb the light. No? Okay. So let's skip that. According to Beer's law naman, no? So if we know the absorbance of a compound, that's equal to A, B, and C. No? So what are those? No? A refers to the absorptivity constant. Okay? So constant yan. B is the length of the cell. No? So length na tong cell na to, path length. Okay. And then C is the concentration of the substance. What's the importance of Beer's law? Ang importance nito is that we know that direct ang relationship ng absorbance with the path length and then the concentration. Okay? So the higher the absorbance, the higher the path length. Pwede. The higher the path length, the higher the absorbance. Okay? Kasi bakit? Kapag mahaba yung cell mo, kapag kunwari 5 centimeter yung cell mo, ganun siya kalaki. Ibig sabihin, mas marami siyang particles na dadaanan. Kaya mas maraming ma-absorb. Okay? So yun ang idea. And since mas marami siyang particles na madadaanan, ibig sabihin mataas yung concentration. Okay? However, if maliit yung path length mo, tas onti lang yung concentration ng species mo, onti lang din yung absorbance niya. Okay? So, yun yung relationship nila. Okay? So, this can be turned into another equation, which is the epsilon BC, wherein epsilon is the absorptivity constant, but this time in units of mole per. This is now in concentration units na. Kanina kasi naka-gram per liter lang na. Naka-grams siya. But this time, naka-mole units na tayo. And this is what we're going to use later on. So, ganun pa rin naman siya. ABC pa rin yan. No? But this time, yung A, ginawa nating epsilon, which means the molar absorptivity. So, that's a constant na. So, we don't have to worry about that. Constant yan. So, yan. For example, ito nga, the higher the distance, sabihin, mas marami siyang dadaanan. Ibig sabihin, mas mataas yung absorbance niya. Pero kung onti lang yung dadaanan niya, onti lang absorbance niya. Okay? So, yan yung relationship nila. Okay. For example, let's do this. A 7.50 times 10 raised to negative 5 molar solution of potassium permanganate has a transmittance of 36.4% when measured in a 1.5 centimeter cell at a wavelength of 525 nanometers. Calculate the absorbance and the molar absorptivity of the solution. Okay, so ano equations na gagamitin natin dito? You know, absorbance is equals to negative log of T. So that's negative log of T. Yung T, di ba naka-percent yan? Usually gagawin mo decimal yan. Okay? So convert mo yan into decimal. So you have 0.364. Okay? Let me clean up my handwriting. Yan. Gagawin mo decimal yung transmittance, ha? So you will get an absorbance equal to, so that is 0.438. Round off natin, 0.439. So that's the absorbance of this setup. Okay, so yun, nasagutan na natin absorbance. Very easy. No? E equals log T lang. So kapag pinapahanap yung transmittance, you can do the anti-logarithm. Okay? So pag hinahanap yung transmittance, the equation to be used is 10 raised to negative log, negative A rather. So that's 10 raised to negative of the absorbance. That's the transmittance. Okay, paano ko nakuha yan? Anti-log mo lang to. Okay? Alam ko, sanay na tayo mag-anti-log. No? And now, about the molar absorptivity. Okay, so when we see molar absorptivity, ang equation na gagamitan ay A epsilon BC. Basta nakita nyo ang units ay molarity, ito gagamitin mo, A epsilon BC. Okay? So yung A dito, gagawin mong epsilon, which is the molar absorptivity. Take note that B is the cell length and C is the concentration. What is the unit of B? Length yan, no? So ang ginagamit namin dyan is centimeter. Concentration, of course, molarity, mole per liter. Okay? Yung absorbance, wala siyang unit. Number lang yan. Okay? So, since we're looking for epsilon, the molar absorptivity, so we can rewrite this equation as absorbance over the cell length times the concentration. What's the absorbance? 0.439 over the path length is 1.05 cm. Centimeter gamit namin dyan. So, hayaan nyo na yan. Okay. And then we have the concentration of the solution. 7.50 times 10 raised to negative 5 mole per liter. Okay. So, epsilon is now what? No. So, divide lang natin. Multiply, divide. 0.439, 105, 7.5, 10 raised to negative 5. So, our epsilon will be 5,574, okay, 0.60 liter per mole centimeter. Okay, so that's how we get that constant. And constant yan. Constant yan. Okay, so ibig sabihin, yan yung epsilon ng KMnO4. So it doesn't matter kung ano yung concentration niya, basta yun yung kanyang epsilon. Okay. Ang epsilon ay depende kung sino yung chemical na ina-analyze mo. Yun yung constant niya. Okay. So again, take note of the unit. That's liter mole liter per mole centimeter. Na ganun lang, no? Mas madali calculation natin compared sa nakaraan. Ayan. So, this time, ginawa niyan scientific notation. Okay? But, yeah, this is the answer. Okay. So, ano yung limitation ng Beer law? Yung A equals epsilon BC. According to this, you can only quantify small concentrations. Hanggang onting concentration ka lang. Okay. So, it should not exceed exceed 0.01 molar. Okay. Kasi, if you exceed that concentration, what happens is that, ganito na. Hindi na siya linear. Okay. Ang focus kasi natin is the linear part only. So, kailangan yung concentration natin pasok dun sa linear range. No? So, yun lang limitation niya. Kapag masyadong concentrated yung chemicals mo, hindi na siya masyadong maganda gamitin. Okay. So, gagawin mo, if you're analyzing chemicals, you dilute it. No? Dilute mo siya. Yeah. So, ang ginagawa namin sa chem, kunwari, mag-extract kami ng chlorophyll ng halaman. Okay, so kung gusto mo i-measure yung chlorophyll niya, extract mo yon. So, kulay green na matingkad yon. I-dilute mo yon. Okay. So, lalagyan mo yun ng, lalagyan mo ng tubig o kaya alcohol, okay, para umonti yung intensity ng color. Then, kapag onti na yung intensity ng color, then you can use the Beer's law. Okay. Kailangan hindi ganun katingkad kasi kapag super tingkad na, masyadong mataas yung absorbance. Ayun, hindi na siya linear pag ganun. Ano pa yung limitation na to? Ayun, kapag may chemical reaction sa ating mga molecules, no? So when you have chemical reactions undergoing with our species that undergo absorbance, yun, so pwede magbago yung ating measurements. Kasi remember, yung species natin has their own epsilon. They have their own molar absorptivity. So kung magbago yung chemical species sa loob, magbabago din yung kanilang epsilon. So yan. So dapat hangga't maaari yung ating mga species dito, they don't react, no? Okay. What else? Ayun, ang limitation pa nito is that if you have stray light, no? Ibig sabihin ng stray light, yung liwanag galing sa paligid, no? So kapag pumasok yun sa spectrometer natin, guguluhin niya yung measurement, no? So hindi na niya ma-measure accurately yung transmittance. Wala rin, binuksan mo yung spectrometer na yan, papasok yung liwanag sa labas. So, magugulo yung reading mo. So, kailangan when doing spectrophotometry, kailangan ay naka-closed ang environment. No? So, kailangan madilim doon sa pinagme-measurean. Ano ba itsura niyan? No? So, let me show you the UV spectrophotometer. Okay. So, ganito itsura ng UV spectrophotometer. Okay. So, ito rin yung ginagamit sa urinalysis, no? So, dito yung compartment, ayan, kailangan nakasara yan. Kasi kung hindi yan nakasara, papasok yung liwanag sa paligid. So, mababasa niya yung absorbance, mababasa niya yung liwanag ng paligid. Magugulo yung measurement niya ng absorbance. Trinay ko yun. Hindi naman siya harmful sa device, no? Pero tinatry ko yun minsan, no? Sa school, ginagawa ko, pag bored na ako, tapos na ako mag-measure. Tapos na ako mag-analyze, then yun, i-open ko yung lid bigla. Tapos makikita mo yung curve biglang tumataas. No? Yung absorbance biglang tumataas. May graph yan na nilalabas. No? For example, ito. When you do measurements, it draws a curve. No? Okay. So, yun. So, kailangan yung ating instrument ay nakasarado parate. No? Ano pa? Mismatch sample cells. Ayun, kapag nagkabaliktad ka ng sample, yun, mali yung measurement mo. Of course, kasi mali yung mini-measure mo. Okay? So, yun lang limitation niya. So, hindi siya okay at very high concentrations kasi it starts to deviate, no? It starts to deviate from linearity. Kaya ganun. Okay? So, let's talk about absorption spectrum naman. So, ito yung graph na sinasabi ko kanina. So, this is the plot of absorbance versus the wavelength. Okay? And for each chemicals, there is a unique spectrum. Okay? So, ito yung itsura ng spectrum na yan. Pag ginamit mo yung spectrometer, which is gagamitin nyo rin naman sa work. Ganito may itsura niya. So, on the vertical axis, you have the absorbance. On the bottom part, you have the wavelength. Okay? So, mapansin mo, iba-iba yung uri ng curve, no? So, ito, depending on the concentration. This one, itong nasa taas, yung nasa cursor ko, ito yung higher concentration. This one below has a lower concentration naman. Okay? So, the higher the concentration of your analyte is, the higher the absorbance will be. Okay? Then, mapapansin mo, iba, ang daming peaks, no? Ang daming peaks, no? Kunwari, ito, isang peak, no? Ito, another, ulit. Okay? So, yan. So, marami siyang peaks, no? Sa wavelength. Ang usually na kinukuha namin dito is the highest wavelength called the lambda max. Yun yung highest peak in absorption spectrometry. Okay, so yan. So lambda max is the highest peak in absorption spectrum. Kaya nga sinabi sa problem kanina, kung magtataka kayo, para saan yung wavelength na to, sir? Yan yung lambda max. No? That is the highest peak in the measurement. We always do measurement in the highest peak. No? Okay. Kasi dun mataas yung absorbance. Dun ka mas makaku-quantify better. Okay. So, yan. So, ano ba yung meaning ng lambda max? Ito yung point kung saan mataas yung absorbed light. No? Ito yung wavelength kung saan mataas yung kanyang absorption. Okay. So, may kinalaman ba yung color na yan sa nakikita natin? Yes, no? Remember na ito yung ating colors, no? Color wheel. Kunwari, nakikita natin yung object as green. Ano sabi nila? It absorbs red light, di ba? Yung sabi ng physics, di ba? If yung nata-transmit niya is green na color, that means it absorbs the complementary color, which is the red. Okay? So, kunwari, may makita kang green object, ibig sabihin, ang lambda max nun ay nasa red color. Nasa red ng wavelength yan. Usually, 600 nanometers na. Okay? For example, ang KMNO4 ay purple. Purple yon. So, it absorbs light at yellow spectrum. Yung yellow, yun yung 500 nanometers. No? Yun yung wavelength ng yellow light. Okay? So, ang KMNO4 kasi is purple. So, kapag in-undergo mo yun ng absorption, it will absorb the yellow light, which is 500 nanometers no, in wavelength. Okay? So, ganun. Kunwari, you have chlorophyll, green. So, you should expect wavelength at around 400 to 500 nanometers. No? Okay. Kunwari, may sample na orange. Kunwari, beta-carotene. If you're analyzing beta-carotene, anong color yung i-absorb niya? Di blue. Okay. So, it should have a wavelength of around 700 something, 600 something. Okay? So, ganun yung idea. So, the light we can see, yung opposite nun, or the complementary color of that, is what they absorb. Okay? Ayun yung sabi ng physics. No? So, ibig sabihin nun, yung absorbed light dito, okay? So, itong 500 nanometers na to, this corresponds to yellow color. Ibig sabihin, this sample is color purple. Okay? So, kung purple yan, it will absorb yellow color. Okay? So, always remember this na lang. Ito ginagawa namin dito. We have this color wheel. So, we have ROYGB. Hindi na namin sinasama indigo. Okay. So, let me redraw this para mas clear. Just remember this diagram. ROY, Roy G. Beef. Okay. So if red yung sample mo, it will absorb green colors. Kung violet sample mo, it will absorb yellow colors. If blue yung sample mo, it will absorb orange colors. Okay? Ibig sabihin, it is always the complementary color. And you know, color corresponds to certain wavelengths. Ito yung colors nila. Okay? So yan. For example, violet, yan. Kapag violet ang inabsorb, meaning yun ay yellow-green na. Okay? So always remember this. Roy G. Biv. Okay? So kung violet yan, it will absorb orange, yellow-green somewhere here. Or yellow. Pag blue yung inabsorb, meaning siya ay yellow. Or orange, somewhere here. Okay? So not exact naman. So this is just an approximation. Ito yung ginagamit namin to give us a hint kung anong wavelength i-expect namin. Okay? So ito yung mga wavelength. So take note of that. Hindi naman kailangan kabisaduhin. Para kunwari, bibigyan ko kayo example. I have green. Hindi. Puro green na yung example ko. Kunwari, may yellow akong chemical. This is my sample. Yellow yung color niya. Anong absorbance kaya yung i-expect ko? Anong absorbance i-expect ko? Of course, the complementary color. Anong complementary ng yellow? Yun yung around violet, no? Violet or blue. Okay? So, yun. Ang complementary color niya is violet or shade of blue. Okay? So, somewhere dito ako mag-expect ng absorbance. Okay? Sa complementary color always. Sa kabaliktaran. Okay? So, ito yung wavelength niya. So, dito sinabi na pag wavelength ay yellow, blue daw, ito yung wavelength na i-absorb. So, dito mo makikita yung lambda max niyan. Okay? Doon mo makikita yung lambda max niyan. So, kapag green off mo yan, pag ganun yan. Okay? Kunwari naman, I have ano kaya kulay? Kunwari, meron akong green. Hindi, nag-green na ako kanina eh. Paulit-ulit yung example na Kunwari, copper sulfate. This is color blue. Asan kaya lambda max niyan? So, color blue yung copper sulfate. Ano yung absorb niya? Tingin tayo sa table. It will absorb yellow color. Okay? So, itong yellow, it has a wavelength of this now. So, kapag yung copper sulfate, kinuha mo yung lambda max niya, yung lambda max nun ay nasa 580 to 595 nanometers. Okay? So, depending on the color of your analyte, it will absorb the complementary color. Yun yung katapat niya sa color wheel. No? And yun yung lambda max nun. Okay? Kung ano yung complementary color niya, yun yung lambda max niya. Okay? So, ito yung lambda max. Ito yung wavelength ng complementary colors or the absorbed colors. Okay? So, ganun. So, alam nyo na expect sa quiz, magbibigay ako ng some samples. Kunwari, ito color green to. Color green siya. Ano i-absorb niya? Hanapin mo dito, asan yung green? Walang green. Ito na lang, green-blue. It will absorb red, no? And ito yung magiging wavelength niya. Okay? Kunwari, yellow-green. Ito naman daw i-absorb niya. Okay? So, ganun yung idea. Parang magma-matching kayo. Ano kaya yung possible wavelength, no? Okay? So, ang gagawin nyo lang, if you have the color of your sample, you determine the complementary color, yung katapat niya sa color wheel. Ito yung i-absorb niyang light. And ito yung mga wavelengths nila. Okay? So, yan. So, anyway, so punta na tayo sa medyo last part na tayo. Patapos na rin tayo. So let's apply let's apply the Beer's law in quantitative analysis now. Ito na-discuss natin to ng chapter 2. Yes, na-discuss natin to ng chapter 2, yung standard calibration curve, no? So what we do in standard calibration curve, we create a curve, no? We create a curve, no? This time that is related to absorbance and the concentration. On the vertical axis, you will have the absorbance, and on the x-axis, you will have your concentration. So, ang mangyayari kasi, the higher the concentration is, the higher the absorbance will be. And we expect it to have linear relationship now. So, we expect that to have linear relationship. Kasi sabi nga natin kanina, if your absorbance increases, the concentration increases as well. Saan natin sinabi yon? Dito sa equation na yon. If you increase the A, you increase the C. Vice versa. Okay? So, the lower your concentration is, the lower the absorbance will be. So, ibig sabihin, we can use linear regression here, which you do in statistics. Pero hindi na tayo gagawa ng super dreadful statistics stuff. We can use technology, okay, to do linear calibration curve. Okay, standard calibration curve. Okay? So for example, this is my standards, no? Again, pag sinabi kong standard, known concentration. So these are my standards and this is my analyte. Determine ko yung concentration niyan. This is molarity. So determine ko daw yung concentration ng aking analyte, ng sample, given yung absorbance niya. Okay? So what we can do here is to plot this. Okay? Ipa-plot mo yan. So kunwari, 0.1 dito siya, 0.2 dito siya, 0.3 dito siya, 0.4 dito siya. Okay, so this is the absorbance, this is the concentration. So magli-linear regression ka sa statistics. Ang ginagawa niyo yun sa senior high school. And then kunwari, yung ating sample of 0.724, ibig sabihin somewhere here yan. Kung nandyan yung ating sample, you can get the corresponding X value, which will tell you the concentration of the substance. So, yun yung gagawin natin, ha? Okay. So, how do we do, standard calibration curve? Tuturo ko muna yung calculator method. Okay. So, let us show how to do the calculator method for this one. Pero kung yung calcul nyo wala, we will use Microsoft Excel. Okay. So, let's go sa calculator. If you want to access the regression analysis, just go to mode. Punta lang kayo sa mode. Then, may makikita kayong stat. Meaning nun, statistics. When you press statistics, you will be given lots of options. You have the one variable which we use to get the mean, the standard deviation. Diba ito yung tinuro ko last time? Sa inyo ba yun or sa lab? Anyway, papanood nyo naman yun sa YouTube. Okay, so yan, this is what we do. This is what we use when we are trying to get the standard deviation, diba? Kung naalala nyo pa. Pero, yung katabi nun, ito yung gagamitin natin for linear regression. AB plus X. Meaning kasi nun, Y equals BX plus A. Or Y equals AB plus X. Linear lang yan. Linear yan. So, ito yung gagamitin mo for linear regression. Let's press that. Okay. So, you will be shown X here, Y there. Okay. So, ano yung X? Again, concentration yan. Yung Y ay absorbance. So, what you're going to do is to plug in all these numbers here. Let me zoom it here para kita natin. So, what you're going to do is to plug in the concentration on the x-axis and the absorbance on the y-axis. Okay. So, hindi kasama yung sample, syempre. Only yung may mga known values. So, yung may mga standard lang. Yung known values lang. Huwag mo isasama yung sample sa dito kasi wala siyang x-axis. Yun nga yung hinahanap natin. Okay? So, let us type it there. Okay? So, una, we have 0.005 and the absorbance will be ay, nagkamali. Okay? And the, yan, 0.005 yan. And the absorbance is 0.212 up to 17. 0.005 to 0.17 ang kanyang absorbance. Followed by 0.01. Ang absorbance niya ay 0.432. Tuloy nyo yan hanggang sa baba. Okay? So, tuloy nyo lang kung ginagawa nyo na siya ngayon. Later on naman, mag-excel tayo. Okay? So, these are our concentrations. You have 0.005, 0.1, 0.01, 0.015, 0.020. And these are their absorbances. 217, 432, 641, 867. Pa-plug in mo lang lahat yun sa CalQ. Again, yung standard lang, hindi kasama yung sample kasi wala nga siyang X value. Now, paano tayo makakagawa ng equation of the line? 'Di ba yun yung ginagawa natin pag regression? You always make an equation of the line. Yung kasi important dito. Gagawa ka ng equation of the line. So, again, ito yung format ng equation natin. Y equals Bx, no? Where Y is the absorbance. This is just the intercept. Okay. B is the slope and X is the concentration. Okay, take note of that. Ganyan gagawin natin. If you plug in everything in your calculator, you should create this equation. Paano kukunin yun sa calcu ko? Ganito, you press AC. Mawawala yan. Then you will access the stat function, itong yellow na stat sa baba. You press shift, then stat. Okay, so again, ano nangyari? Press mo yung AC, you press shift, then stat. Then may makita kang options, you choose the regression, the reg. Okay, pindutin mo yung 5. So it will give you lots of options. You have the R, you have the B, you have the A. Okay, so R, this is the Pearson correlation coefficient. Do you remember that? According to statistics, Pearson correlation coefficient tells you about the lineness, no? It tells you about the fitness of the curve in a line. So if that is equal to 1, ibig sabihin that's a straight line. If that is not equal to 1, ibig sabihin hindi yan straight line. Okay? So, sa statistics, di ba, nakikita nyo yung ganito. Hopefully, naalala nyo pa. Sasabihin yan, no correlation. So, regression is 0. Pearson correlation coefficient is 0. Pero kapag ganito naman, R is equals to 1. Naalala nyo yun sa stats? Yun. Ito yun. Yung R. Ba't tayo nag-stats dito? Ganun talaga. Wala tayong magagawa. Okay? So anyway, so stats lang yan ha. Hopefully naalala. Kunin mo muna yung R. Baka ginagamit namin to pan-check, no? Kung tama yung ating mga pinagtatype. Yung R is square mo yan and you will get this. Sulat mo yan, R squared equals, ini-square talaga yon kasi di ba ganun sa stats. Okay. So our correlation coefficient is 0.9998, no? Pag ni-round off. Yun yung ideal, no? When doing chemical analysis, no? Or spectrometric analysis, kailangan yung regression mo ay near to 1. Okay? Medyo impossible makakuha ng 1, pero at least near to 1. Wag yung 0.8, pangit yun. Kailangan 0.99, no? Para linear talaga. Okay? So, since maganda yung ating data, paano natin nasabi na maganda yung data? Yung regression squared niya is 0.9998. No? So, good yon. Pero kapag yan ay 0.8, medyo pangit yon. Okay? Medyo pangit kapag 0.8, 0.7, especially kapag 0.3. Pangit talaga yon. Hindi mo magagamitin yung linear regression doon. So again, kunin mo muna yung R-square to check if maganda yung data mo. Then you press cancel uli, shift, then balik ka uli sa stat, regression. Now, gawa ka ng equation of the line. So, let's find B. Ito yung value ng B. So, y is equals to 43.18x plus the intercept. Okay. So, yun yung B natin, di ba? Bx. So, ito yung slope of the line, 43.18. And how about the intercept, which is the A? Balik ka ulit doon, you press this. Negative sign pala. Okay, so minus 5 times 10 raised to negative 4. Okay, so y equals bx plus a. Ito yung b, the slope of the line. Ito yung a, which is the intercept. Now, balik na tayo ulit dito. Pag gusto nyo balikan yung pag-plot sa calculator, panoorin nyo na lang ulit sa YouTube mamaya. Okay, so yan, na-plot ko na yung ating curve. No? Ngayon, hanapin ko na yung sample. Alam ko yung absorbance niya. The absorbance is 0.721. Pero ano yung concentration niya? Okay. So, ibig sabihin nun, yung y alam ko. If y is equals to 0.724, what is x? Ito yung gagamitin kong equation. Hahanapin ko yung x dyan. So, let us derive how to get x. So, y equals 4318 minus 5 times 10, negative 4. O, yung intercept, lipat mo sa kabila. So, you will have y minus, this will become positive na. Divide mo yan by 43.18, you will get the x. You can get the concentration na. Okay? O, ano ba yung y natin? 0.724. So, lagay mo doon, x equals 0.724 minus, plus 5 times 10 raised to negative 4 over 43.18. So, malalaman mo na yung concentration mo. Simple algebra lang. Again, yung x yung concentration, yung y absorbance. So, kung ito yung y mo, hanapin mo na lang yung x using this equation. Okay? So, let me plug it into my calculator. So, the concentration is 0.017 molar. So, that's the concentration if the absorbance is 0.724. Okay? Ayun. Ganun lang. No? So, you create, you do regression analysis. Okay? So, you do regression analysis. And then, ayan, no? You derive the value of x if yung y ay known. Okay, so ganun lang. So ngayon, what if wala akong calculator na ganun? Pwede kayo mag-download ng calculator na ginagamit ko. So, sa Casio website, download nyo lang to. Tinuro ko na yung steps dati. Okay. So, download nyo na lang to sa Casio website. 90 days nga lang yan na trial kasi may bayad yan talaga. O kaya, you can use Excel naman. Now, let me show you how to do that in Excel. So, yan. I plug in the concentration and the absorbance. This is the concentration. This is the absorbance. So, gagawin mo, gagawa ka ng graph, no? So, you select this. So, you select this array of data. Okay? So, select mo yung lahat. Huwag isasama to, ha? Ito lang. Then, you go to Insert. Then, dito sa charts, may makita kang ganitong symbol. Scatter tawag doon. So, you will choose Scatter. And then, you will click this. Again, ano uli ginawa ko? Dahan-dahan. Highlight. Insert. Scatter. Yun. So, nakagawa na ako ng curve. No? Nakagawa na ako ng plot. No? So, on the vertical axis, I have the absorbance. On the horizontal axis, I have the concentration. Okay. So, paano ako gagawa ng equation of the line dito? Mas madali. Gagawin mo ganito. Di ba may dots dyan? You just press one of them. Press mo lang isa doon. Then, right-click. May makita kang add trend line. Again, paano uli? Pag nakagawa ka na ng curve, select mo yan. Click mo yung bilog na yon. Then, mag-right-click ka doon. Add trend line. So, let's press the add trend line. Ayan. Ayan. Always choose the linear kasi nga linear regression tayo. Pag ni-scroll down mo yan sa baba, you can see some options. You can display the equation and then you can display the R square. Diba ito rin yung nakuha natin kanina? Ayun din yun. Zoom in ko. Yan din yung nakuha natin kanina, di ba? For 3.18 minus 5 times 10 to the negative 4. And the R square is this also, 0.9998. Okay? Ibig sabihin, mas madali mag-Excel. So again, let me do it one more time. Right-click. Wait lang, delete ko muna yung trend line. Right-click mo yan, add trend line, choose linear, then i-check mo yung equation and the R-intercept, and the R square. So now, you have the equation of the line. So, ikaw na bahala mag-plug in. Balik ka uli dito sa pag-plug in ng X value, ay ng Y to get the X. So, ayan, basta mahalaga, nakagawa ka ng equation of the line. Yun naman yung important dyan Makagawa ka ng equation of the line and making sure that the line is linear. Okay, so now you have two ways to do that. You can use calculator or you can use Excel. If you have calculator, it will be better if you practice ngayon pa lang. Okay? Kasi alam ko magagamit nyo rin to sa biostatistics nyo. So it will be better if you know how to do it on a calculator. Kami kasi kailangan namin kabisaduhin yung process. Kasi sa board exam, di ka naman pwede magdala ng laptop. Hindi pwede mag-laptop sa board exam, malamang. Okay? Kaya, kailangan alam mo yung gagawin mo sa calculator. So, what I suggest you to do is to invest in a good calculator which is allowed by PRC. You can look that sa website nila. Hanap kayo ng calculator na may statistics, no? May statistics function o kaya equation function. I will recommend you Casio 991 Hindi. Hindi siya 991. Casio 570. Yun yung ginamit ko nung board exam. Kaso nawawala siya eh. Hiniram ng friend ko yun eh. Ito. This is allowed in the board exam. Casio 570. Meron tong equation. Meron din tong regressions, statistics. No? So, you better choose this kasi ito yung similar with 991 ES Plus. Ang difference lang niya, wala siyang solar panel. I don't really know bakit bawal yung may solar panel. Sabi nila programmable yon pero I don't know how. Paano na pa-program yun? But this is allowed in the board exam, so better have this one. Yung binibili nating class quiz, ako I both class quiz kasi tapos na ako mag-board exam. Pero nung hindi pa ako nagbo-board exam, di ako bumibili nito. Kasi alam ko hindi to pwede sa boards. ito yung binili ko. Mura lang to, no? Mga ganitong calcu. Just look up sa Shopee. Itong class quiz ko, nabili ko to sa Shopee for 1,000 lang. 'Di ba sa National Bookstore, ang class quiz ay 1,500 mahigit. At least sa Shopee, legit na. Mura pa. Matagal nga lang delivery. So, yan. You start investing on calculators as early as now. Kasi ang gagamit nyo rin yan sa boards. Kasi nga, bawal mag-laptop sa boards. Hindi ka makakagana ito sa boards. Okay. So, yun lang. Close ko na yan. So, that's how we quantify yung ating concentrations, no? Depending on the absorbance. So, dito pumapasok yung sinasabi ko sa sa urinalysis, no? Okay? Okay, so ganun yung ginagawa diyan. Ito pakita ko example. Ito yung sinasabi kong paper. Ito yung ihi, no? Yan yung urine. Then this is the paper. Lulublub mo yan doon and then yung intensity ng color magbabago. Okay? Iba-iba yung absorbances nila. So, i-compare mo lang yun with compare mo yan with this table. So, depending kung sino yung nakamatch niya, yun yung concentration ng kanilang components doon. Okay? So, ganun gagawin mo. Lulublub mo yan dito, then magbabago kulay niyan, then you compare it dito. Okay? So, ganun lang. Although, syempre, merong advanced ways to do this, no? Ayan na. Compare mo siya doon. Merong advanced way to do this naman, yung computer na yung bahala, no? So, ilalagay mo yun sa colorimeter, no? Which is a form of spectrometer. Pakita ko kung ano itsura ng colorimeter. Gagawin mo yung paper na yon, ipapasok mo dito. Ayan. So, yung paper mo ipapasok mo dyan, then siya na bahala magbasa ano yung concentration. Ipiprint na niya yun. Ganun ginagawa sa laboratory. So, hindi ka na magko-compare isa-isa, no? Bahala na yung computer to measure kung ano yung concentrations niya. Okay? So, yung application niya sa medtech field. Okay. So, ito naman, medyo hindi na siya necessary, pero daanan na lang natin, no? So, absorption spectra. Okay. When you say absorption, yung energy ay na-absorb ng atoms, no? What happens ba when atoms or molecules absorb energy? They go to excited states, no? So, when you say excited states, no, the electrons are transitioning from lower energy level to higher energy level. Remember sa Bohr model, ito yung atom, then ito yung mga orbitals niya. If the electron is here, pag yan, nilagyan mo ng energy, aangat yun. Aakyat yung kanyang energy level. Okay? So, yun yung nangyayari when we have absorptions. No? So, what will happen is that when the atom absorbs energy, it excites its electron umatalon yung electron niya to the next energy level. Okay? So, depending on what energy level will it jump, there will be a corresponding wavelength for that. Okay? So, yun yung idea lang dito. Again, kapag yung atom nag-absorb ng energy, yung electrons niya, it will jump from ground state to the higher energy level. From lower to higher energy level. Kasi nga, nag-absorb siya ng energy. Okay? So, maraming nangyayari when that energy is absorbed, no? For example, your molecules can undergo rotational and vibrational motion. Ito yung nangyayari sa microwave, no? So, for example, sa microwave, nilagay mo, in-on mo na yan, di ba? Tutunog yan. Gaganon yan, di ba? So, naglalabas yun ng microwaves, no? Literal na microwaves, no? So, mangyari, if, kunwari, may food molecules dyan, let's say water, tapos ito yung microwave, pag natamaan niya yung water molecule niyan, it will start vibrating. And then, ano mangyayari kapag nagva-vibrate yung molecules? It is similar with your hands. Galaw-galawin mo yan, umiinit. Okay? Yun yung nangyayari dito sa microwave, no? So, if you apply energy, no, microwave, no, sa food, vibrate mo yung hands mo, umiinit. Ganun din nangyayari sa food, no? So, yung mga molecules niyan, they are literally moving, okay? Because of the absorption of energy. So, maraming modes yan. We have the symmetric, asymmetric, but we will not discuss them in depth. Ito naman yung nangyayari sa molecular absorption. So, yun nga, transition to from low energy levels to high energy levels. Okay? Infrared radiation or even, by the way, ito yung microwave, no? Sa microwave, ganito lang. Sabi ko na pala. Pero kapag meron kang infrared radiation and UV-Vis radiation, they are more energetic than microwaves. Okay. So, ang nangyari lang dito sa infrared is ganun pa rin, vibrational or rotational lang yung transition. Kaya umiinit kapag may infrared rays. An example ng infrared rays, heater. Okay. So, yung heater natin, umiinit yon. So, yan. Meron kasi yung infrared rays na nilalabas. Ito nga yung ginagamit ng yung infrared thermometer. So, depending on the infrared rays you emit, there is a corresponding temperature for that. Yan yung ginagamit sa LRT or sa NAIA. Okay? Kaya nag-glow yung mga tao doon, di ba? Papansin nyo, nag-glow yung tao sa infrared thermometer kasi nga, we literally glow because we are emitting energy. Okay? May glow talaga tayo, hindi lang natin nakikita. Kasi nga, visible lang yung kaya ng eyes natin. Tapos, sabi natin, UVVs or UV and visible lights are more energetic. No? So, it can really jump the electron from one energy level to another. Okay? When you say emission spectra naman, kabaliktaran to ng absorption. So, ang absorption is from low energy level to higher energy level. Okay. So, when you apply energy to this in the form of electromagnetic radiation, you excite the electron. Okay. Absorption yun. And when you excite the electrons, maraming nangyayari. Mag-vibrate yung molecules o kaya tumalon siya to higher energy level. Okay? Pag emission naman, kabaliktaran yan. Gagawin mo, yung high energy level electron, magre-relax siya, relaxation. So, as a result, siya naman yung maglalabas ng liwanag. Kaya nga emission, siya yung maglalabas ng light. Atong absorption, siya yung absorb ng light, so aangat yung electron. Sa emission, yung electron, pag bumaba yan, it will emit light. Okay? Okay. So, from that, we can create line spectra. Okay? So, each atom has their own emission spectra or line spectra. And ginagamit din natin yan for, this is what we call the infrared Ano ba to? Brahman ba to? Yeah. So this is, I think this is Raman spectroscopy. Pero hindi na natin madidiscuss yan kasi pang BS Chem na yan. Anyway, so from the emission, depending on the energy emitted by the relaxation of electrons, you can identify the atoms using line spectra, or you can determine the molecules using band spectra. Okay? So yan. You can also have continuous spectra. Sa physics na to. Hindi na namin ginagamit yan sa chem eh. So sa continuous spectra naman, depending on the emitted wavelength, you can determine your materials, no? Okay. Pag fluorescence spectra naman, fluoresce meaning liliwanag. Okay. So yan. Your atoms can also fluoresce, no? Okay. So pwede rin sila lumiwanag corresponding to certain wavelengths, no? For example, yung sodium, liliwanag yan as yellow. Okay. Ano pa? Yung copper, kulay green yan kapag lumiwanag yan. Okay. Sa molecular fluorescence naman, ang isang example niyan is yung yung luminol, no? Ang mga chemiluminescence natin, yung mga glow stick, ayon. So they emit energy, yan. Anyway, it's just dito naman energy transitions lang yan. Okay, so yun lang. So we're done with chapter 6 na. So ano yung takeaways natin ngayon? Ang takeaways natin is that number 1, light interacts with matter. Because according to Albert Einstein, there is what's called the wave-particle duality of light, the dual nature of light. No? Nababasa niyo yung chat box namin sa Lasal. Sarado ko muna. Ay, hindi siya nasara. Close ko na yan. Na-move kasi exam namin kaya napangiti ako. May exam kasi kami kahapon, napaka-dreadful. Iyak, nakakaiyak eh. 3 hours kami nag-e-exam sabay-sabay. Tapos nakatulala na lang ako. Anyway, so buti naman na-move yung isang subject. Okay, so ano gagawin natin? So yun nga, we know that light interacts with matter kasi according to Einstein, there's a light wave-particle duality of light. No? So by using that interaction of light with matter, we can quantify them in a field of study called spectroscopy or spectrophotometry. Okay? So maraming uri yan. We have the absorption, we have the emission. We have the chemiluminescence, we have the phosphorescence, no? So ganun. So kabisaduhin nyo lang yung mga meaning nun, nasa PowerPoint naman. Ang isa pang takeaway natin is that depending on the absorption, you can get the concentration using Beer-Lambert's law, the A epsilon BC, where epsilon is the molar absorptivity, and the B is the cell length, which is in centimeters, and the concentration is in molarity. The failure of that is that when your solution is very concentrated, so hindi na siya linear. As much as possible, you use dilute solutions only. Hindi rin siya pwede sa invisible solution. Kailangan colored, no? Kasi nga, sabi ko, kapag colored, dun nagkakaroon ng absorption. Dun mo pwede gamitin yung Roy G. Biv, no? So, speaking of Roy G. Biv, if your object appears yellow, yung i-absorb niya is the complementary color. Yun yung nasa other side, no? So, ang nasa other side nun is around violet color. So, if yellow yung iyong substance, it will absorb violet light. Kasi nga, complementary yung ina-absorb parate. So, if kunwari, you have green for nickel. Nickel is green pag naging solution yon. So, isip tayo, Roy G. Biv, ang katapat ni green ay red, no? So, ibig sabihin, the wavelength or the lambda max will be around the red colors. So, nilagay ko, nasa PowerPoint na rin yung corresponding wavelength. So, take note of that. So, probably expect that yung quiz natin ay may multiple choice, obviously. So, we have a multiple choice there. Okay, so may multiple choice tayo na magsama-sama na yung terms, no? And then, andun yung ilang calculations, no? And then, may free response question tayo. Yung kayo mismo magta-type ng sagot nyo. Okay. What is the concentration? Nata-type yung sagot niya. Okay. So, ganun lang. Expect na ganun yung quiz natin. But, again, this topic is relatively easy, no? Parang nakahinga tayo ng maluwag kasi wala na tayong mga wala na yung titration, wala na yung E-cell, di ba? So, yun. So, basically, tatlo lang, iilan lang equation na gagamitin mo. Yung frequency times wavelength is equal to C, or lambda times B equals C. Delta E equals HC over lambda, or delta E equals H nu. Okay. Ano pa? A epsilon BC. C. Absorbance equals epsilon BC. Ano pa? Transmittance equals transmitted over incident. Okay. So P over P 0. Then absorbance negative log of T. Yan lang. Yun ang mga equation na ginamit natin. No? So hopefully may natutunan tayo today, no? Na relevant sa ating field kasi again, sabi ko nga, in your future studies, no, kapag kayo ay nag-work na or nag-masters, ang ididil yung instruments ay yung mga diniscuss ko sa laboratory dito sa subject natin na to. Yung spectrophotometer, colorimeter, yun. So, yung mga yun na yun, lahat yung gagamitin nyo.